Okay, so it should be in Google Classroom. Okay, go to Classroom and then into Classwork. It should also be on the screen because I just posted it there. Okay, so you see here, posted a new assignment, position versus time lab. Okay, if you click on it, you will see that there are, and you actually click View Assignment. There's two files here. The PDF you're not really going to need right now. Okay, and you're also not going to need the data. That's basically just for anyone who's not here today. Okay, who's going to need the data from home. They're going to use that because we're going to get our own data here in the classroom today. Okay, what you need to have open is the Your Work Google Doc over here. Okay, click that, open it up, and we're going to talk about the design and hypothesis and all of that kind of stuff. Okay, so that's where we'll be working from today. All right, so the way this lab is going to work is as follows. We're going to have these little carts, okay, and they look little and unassuming. I assure you they are actually high-tech and expensive. All right, so please be careful with them. Don't drop them or anything like that. I really feel bad, actually, I haven't done that now. Anyway, we'll be using these, and we're just going to try and get a short amount of data of the cart traveling at a constant velocity. Okay, the way that we're going to do that is we're going to put them on the tracks. Okay, there's plastic tracks and there's wooden tracks. They work equally well. Okay, you're just going to start the cart in the grooves for this cart. There's two sets of grooves. We don't use the big grooves anymore, so just the little grooves. Okay, make sure the wheels of the cart are in the grooves. And you'll also notice that on the carts there's an X, Y, and a Z, okay, indicator here. This is the front end, okay, so the end of the bumper is the front end. Okay, if you don't do it that way, it's going to register that it was moving backwards when you started moving. Okay, so you're just going to set it on the track, okay, and the person who's doing the data collecting, which I'll talk about here in a minute anyway, is just going to start the timer. Once they start it, you're just going to give it a nudge. That thing might pop out, it might not, don't worry about it if it does. Okay, and all we want is just to record it traveling at a constant velocity along the track. Okay, we only need a second to a second and a half's worth of data because this is going to be a recording at 20 hertz. That means it's going to be recording 20 data points per second. All right, so we'll get plenty of data even over that short distance. Everybody with me on that? Okay, you're going to do two trials. Okay, the first trial, you're just going to give it a little push. And we should probably use the metal tracks because it seems like these are pretty high friction right now. Yeah, that was a little better. Okay, so give it a little push for the first one and give it a bigger push for the second one. We are going to have to edit our data a little bit because obviously there's going to be a short period of time where it's accelerating because we're giving it a push. Okay, we're only really worried about the part where it's after we're done with it. Do have somebody at the other end of the ramp to catch it. Okay, and in fact, if I can request, please do this on the floor. Okay, because these are expensive. If they go flying off, okay, the end, they'll break. Okay, they'll break for sure. So just make sure you're doing that on the floor so that they can't fall very far. Okay, this little thing here is for momentum experiments. You'll use it in Physics 30, but this little button here is the, okay, that's what releases it. So anytime you accidentally touch that little button, that thing's gonna fly out. Okay, don't let it scare you. Don't let it make you drop the cart. So for me, just have it in the out position all the time and it'll do less of the work. Okay, we'll talk about how you set those up in a minute. Anytime you're not using it, if you're setting it on the desk, please set it on the desk like this. Okay, wheels up, please. Inevitably, I have people set these on the desk, wheels down, and then they're scrambling because it's going to roll off. Okay, all right. So the problem we're investigating today, and you might want to get ready to type here, okay, you have to put this in your own words in the form of a question. But what we're investigating is how to calculate the speed of an object from a position time graph. Very simple. Okay. So for identifying our variables, in any experiment, what variable goes on the x-axis, manipulated or responding? your manipulated variable always goes on the x-axis anytime you're doing an experiment. Okay, so in this experiment, okay, we are graphing the position of the cart as a function of time. Okay, that means that the longer the cart is allowed to travel, the more its position will change. Okay, are you seeing which one we're manipulating and which one is responding? The longer I allow the cart to travel for, the farther it will go. Okay, now remember, when you're identifying your variables, you need to explain them as well. So when we're explaining the manipulated variable, okay, which, spoiler alert, is time, okay, you need to say how you're manipulating it and how it will affect the experiment. Okay? Now that's going to seem weird because people, as soon as I say manipulating time, people are like, you can't manipulate time. Like, what, do you have a time machine? No, I don't. Okay? But I can manipulate time. I can determine how long the experiment will run for. That's manipulation of time. I determine the length of time the experiment runs. That's a manipulation of time. Okay? All right, you can figure out how to explain the responding variable. You also need 3 controlled variables. Okay? Your controlled variables can fall into 2 categories. They can be conditional, sometimes also called environmental, or they can be procedural. Okay? Usually you try and find at least one of each. Okay? Obviously you're having 3, so you're going to have 2 of one and 1 of the other. Okay? So what we're looking for here for our controlled variables are anything that could affect the responding variable other than time. Okay, so you need to think of 3 things in this lab that you need to keep the same that could affect the position and the velocity, actually, of the cart. Okay, so what are some things about our experimental setup or the environment in which we are running it, okay, that could affect both the position and the velocity of the cart were they not controlled? Right? I'm going to give you a hint on one of them. We're going to have the tracks like this, not like this. Because one way would result in a constant velocity, and the other way would result in what? Acceleration. Okay? You guys kind of following what we're looking for there? Okay. All right. You need to explain each controlled variable separately. Okay? Don't just say, these are the 3 controlled variables, we're keeping them the same so they don't affect the lab. Not good enough. Okay? This variable is being controlled. So incline of the ramp is being controlled because, right? And also how. Ramp's going to be flat. That's how. Okay? Why are we controlling it? Okay? Say that for each of your 3 controlled variables. Okay, a hypothesis always contains 3 words: if, and, then. Okay, no, a bunch of you are still scrambling to get your control variables, but we'll have time for that later. Okay, for the hypothesis, if, and then are the 3 words that go in a hypothesis. The if part deals with the premise of the experiment, okay, or the relationship between the manipulated and responding variables. Okay, the and part briefly describes the experiment, and the then part predicts your results or states what you're going to find or be able to do as a result of getting your data. Okay? So for this experiment, the if part needs to talk about how position relates to time for an object traveling at a constant speed. I would suggest describing that relationship as it would appear on a graph. The relationships that can appear on a graph are things like exponential, inverse, linear. Okay, what kind of relationship is position and time going to have, are position and time going to have, okay, in this experiment for an object traveling at a constant velocity. Okay, and just so you remember here, okay, a linear relationship looks like this, an exponential relationship looks like that, okay, an inverse relationship looks like this, okay, inversely exponential looks like that, okay, and so on. Right? There's lots of different kinds. Okay, which one do you think is going to fit best for this experiment? So you would say if there is a blank relationship between position and time for an object traveling at a constant velocity, and okay, the and part just describes the experiment. A cart is allowed to travel at a constant velocity while its position and time are recorded. Something, I don't know, that's what we're doing. Okay. In the then part, you need to tell me how you will calculate velocity from your graph. Okay? Spoiler alert, it's not with this. We talked about how you can get velocity from a position versus time graph yesterday using that. Okay? Since the analysis is going to ask you to do that. Okay? That's what we want to do.
Is this looking at speed and velocity? Because for the problem you said, how to calculate the speed.
Did I say speed in the problem? I meant velocity. I'm sorry. That's my bad. I meant velocity. Although, for this experiment, they would be the same. Right? Because the cart is traveling in a straight line. I should have said velocity. So that's my bad. Okay. So we'll talk about the procedure here in a minute. For the analysis, okay, the analysis is pretty straightforward. Okay. So you're going to use Google Sheets, and I'll walk through again how to do that in a little bit here. Okay, you're going to plot a position versus time graph that has both runs, not obviously both carts. You're going to be using the same cart for each. Okay, plot it on it, and using y equals mx plus b, determine the velocity of both cars. I'd like to see your work here. Okay, so the way you show me your work, either you type it out or do it on paper, snap a picture of it, and insert the picture into the Google Doc. Okay, I don't want to have 4 different pictures to look at in addition to your Google Doc. Put them in the Google Doc for me, please. Okay. All right, then for your conclusion, copy and paste your hypothesis down to here, and then using your data and your analysis, explain why you can accept or reject it. Okay, you said it would be this kind of relationship. You said you'd be able to calculate velocity by doing this. Were you able to do that? Okay. Did that work? Did it have the relationship you predicted? And then for evaluation, okay, 2 sources of error and ways to fix them. All right, so when you're watching this, I always suggest to people, when you do a lab, just shoot a quick video of it with your phone. And then you can always come back to it and see if you can find any sources of error that may have been present, okay, within the lab. Okay, because then you see it, you can still hear it. Sometimes there's audio cues kind of to sources of error and things like that. All right. Questions so far? Okay. Now I'm going to pause the recording here because there's no sense recording how to use the SmartView software because you're not going to need that later. Okay, so you're going to have your file. It may still be entitled exporteddata.csv. Okay, we had this one. Shane renamed this one to position versus time.csv, but it's still the data. Okay, so if you click on that, it's going to look like this, which is awful. Okay, I don't want it to look like that. I can't edit it like that. It's got way more data than I need. That's okay. Okay, here's what I'm going to do. Click up here, open with Google Sheets. Okay. And it'll take a minute because Google Sheets has to think about what it's doing, okay, and convert it. And now it looks like this. It's still all that same messy data that was there before, but now we can get rid of the stuff we don't need, right? The first thing we don't need is the date and time. Okay, so just click on that and delete that column. You don't need it. Okay, you do want to keep this, the time in seconds for run 1, because that's hopefully the longer of your 2 times. Okay, because you did the soft push on run 1 and the hard push on run 2. Okay? All right. I don't need the force for run 1. Okay, so I can delete that one. Okay, I don't need the acceleration. Okay, I can delete that. In fact, I can just highlight a whole bunch of these, okay, and get rid of them all, right? Like that. Okay, I want to keep the position here. Okay, I'm going to keep that column, so delete selected columns. All right, I'm going to keep my position, and I'm going to delete all this other stuff all the way over here to like date and time. Okay, so we'll get rid of all. Okay. Okay, so now I'm just going to double check here between run 1 and run 2's times and see which one is longer, because I want to keep the longer time, which is run 1. Okay, so I'm not going to keep the time for run 2. Okay, all I want to do is delete everything except for the position for run 2. Right, so I'm going to even delete the time for run 2 because it, for me at least, is the shorter of the 2 times. So I'm going to delete all of these. Okay, I'm going to keep position there and delete everything else. All right, so now all I have is time and 2 sets of position data. Now I can build my graph. Okay, so to build your graph, in case you've never built a graph in Google Sheets before, okay, click in the top box, click and drag, highlight everything. Okay. Then go to Insert. And you want to insert a chart. Okay. When you click on that, Google Sheets sometimes picks the right type of chart. Okay? In this case, it actually did pick the right chart, which is a scatter plot. Okay? If it didn't pick that for you, just go over here to where it says chart type. Click on the down arrow and just go down until you get to scatter chart, which is usually down here near the bottom.
I missed one.
Do we get graph or chart?
Okay.
Yeah, I'm highlighted.
I gotta highlight it.
Highlight everything. Insert. Chart. Okay, you want a scatter chart.
Wait, how do you move from over?
I'm going to show you in just a minute, just wait. Okay. All right, now that I've got my chart built, I still need to fix a few things. First off, this title sucks, okay? I don't want the title to say run 1, run 2, okay? I want it to describe what's on the graph, right? So we can just click in there if we want, or if we go to customize, we can change the chart axis titles. Okay, so if I want the chart title to be something else, I just change it here. Position versus time lapse. And I need to make sure that my axes say the right things. I don't want my horizontal axis title to be time in seconds run 1. Just time in seconds will do. And I also want to have a title on my vertical axis, on the y-axis. There's no label there, and a good graph has got both axes labeled, right? So what's going on our y-axis? Position. In meters. Okay, so now I've got those. Next thing I want to do, okay, is I want to go to series. And guys, I'm recording this, so if you get behind me, you can watch the recording again later, okay? Go to series, okay, and you can change a few things about the lines and the points here. I usually make the points smaller so that they don't look quite so like huge on the graph, and that's up to you. Here's what's really important about your series. You need to scroll down from the series menu here, scroll all the way down to where it says trend line. Okay? If you check that box, it will draw a best fit line for both runs, like so. Okay? When you click trend line, you get a whole bunch more options below that. Those options include a label, and you definitely want this. It will spit out the equation for that line for you. So click on label where it says none, and highlight and click use equation. When you click on that, you'll see up top here that it now has that y equals 0.443 times x plus negative 0.0988. Okay, it has spit out the equation for the line for each one of your runs. Okay, now right now that equation is kind of meaningless because I got a bunch of data in here I don't want to keep. Okay, I've got this part of the data here where the cart wasn't moving, and this part of the data up here where the cart wasn't moving, and I don't want to include those points. So here's how I edit those up. Now I get out of chart editor because I have everything on there that I want. I pull this over to the side. Okay, so I'm just going to go up into my points here. Obviously, I don't want to keep all these zeros. Okay, probably want to have 1 0, saying it started at 0, but I don't need all those zeros. And if you get any points that look like this 8.49 times 10 to the minus 4, that was probably when you were just giving it a push. It probably just moved backwards a tiny bit, okay, and it just recorded that. Okay, so what I'm going to do is delete the data I know is irrelevant by doing this. Just highlight that data. And right click on it. For you guys on the Chromebook, that's 2 fingers on the tab, on the mouse pad, and 2 fingers at the same time. And just delete those cells. Okay, so you go down here where it says delete cells, and then you want to shift up. Otherwise it'll leave them blank. I don't want the blanks in there. I want the data below to come up and fill the spots. Okay, so you click shift up. It moves up. Now, if I go and look at my graph, okay, I've eliminated some of those first points, okay, and it changes my equation over there. Now it says 0.454, and my y-intercept is different. Okay, so I still have a few dots here that I probably need to get rid of, and that's why I need to keep going back to the graph. Okay, you can see these kind of flat ones and this little bit of a curve here that I don't want. Okay, I just want the part where it traveled at a constant velocity. So now I'm going to go back up, and if I have this highlighted and I put my pointer on the graph, it'll actually show me which point I'm pointing at. And then I can go back and make sure I delete that one and the ones before it. Okay, so the value for this one is 0.38. That's probably where I want to start, or maybe even this one just before it. Okay, this 0.233. I think that's where I'll start. Okay. So I'll go back up here. So that's the one I want to start with. So I'm actually going to delete these ones as well. And shift them up. Okay. Now I also know I've got a bunch of ones at the end that I want to get rid of. Okay. So I'm going to scroll down, probably move my graph up here. Okay, so these points all in here that are all the same. They're 1.0 whatever, right? So I'm just gonna put my pointer over that one. There's the first of the, so 1.0652. So that's right here. So I'm gonna delete everything below that, because those are irrelevant points as well. Okay. So you can see how on my graph now I've just got that part of the line that I wanted, where it was traveling at a constant velocity, okay? Everybody all right with that? Okay, and I want to do the same thing for the red line, okay? So I probably want to start with this point here, so I just have to click on my graph again. Right, so 0.02 is the one I want to start with. So that point right there, so I'm going to delete all these other ones. Shift up. Okay, and then I'm going to do the same thing I did on this graph and get rid of these ones at the end. So that 1.04 is probably the one I'm looking at. There. Okay, so now my graph looks like it should. I've got all the erroneous points off. Okay, I've got good data, I've got equations that make sense. Okay, now I can go from there. Okay, so now that I've got that graph built, I just want to put it in my lab report. So you just click on the three dots here, and you go copy chart, put it in your Google Doc. Okay, just go over to your Google Doc and paste it. So if I go copy chart, and okay, go to data, insert your charts here, and paste. There it is. All right. If you're having trouble with any of that, let me know.